on to step 4 of our 4-step process. I want to talk about CNC heads and how we do things here at S&S. Our CNC head is essentially you take your stock cylinder head, send it to S&S, and we will basically punch the guides out, put new guides in it, CNC the port, CNC the chamber, deck the head, and put it into a configuration that is all ready to go for performance. Basically, you're getting our cylinder head without buying the whole head, and of course it's much more affordable than a head. You're looking at $950 versus a whole cylinder head, depending on options, could be as high as $1,400. So what we do is cylinder head would come in. Basically, I have a stock cylinder head here. It's of course got carbon in it, bore. It's going to have oil all over it. Still has the springs in it. We pull all the stuff down, discard the valves and springs, and inspect the head to see that it is acceptable. Like if the head's already been decked, of course it won't work for our service because the material is not there, and so we wouldn't be able to maintain the chamber size that we're looking for. There's all kinds of criteria that maybe you got stripped threads, that kind of stuff that we need to be aware of as we are clamping them on our fixtures, that kind of stuff. So we'll inspect the head, and then we get the head disassembled. We'll put it in our CNC machine. They'll port the intake and the exhaust. When it comes off the CNC machine, basically it's going to look very similar to this, minus the guides. Okay, the transition, through the bowl and seat area when we cut the seats will blend out, and you can see that not all of the port will clean up, and that's perfectly fine, because the reason for that is we can't control the castings. The castings kind of float around and don't maintain the tolerance that you do with a CNC machine. So it's perfectly normal to see a port that doesn't clean up. Now, like this exhaust port here, there's a lot of material in there that hasn't cleaned up, and that's okay. I guess what's important is that it cleaned up in and around the bowl area here, and we don't have big steps and misalignments. Okay, some more information about the ports. When we did these ports to put a 1/900 intake valve in here, we leave the seat alone. It's a stock seat. We just cut it bigger and sink the valve. And then the ports, when we developed the ports, we tried to keep them as small as we could. And that's kind of how these are a lot different than our standard port, in that this port is very small for the valve that we put with it. So what that means is, of course, you're trying to get more air through a smaller area, and that equates to more velocity. And velocity is key. You can't have too much, but the high amount of velocity, of course, creates more turbulence and therefore better combustion and more power. So we're getting more air in for the size of valve with a smaller port, and that equals better turbulence, better velocity, and more performance. In a nutshell, that's pretty much what we have. Now, when the guides go in, we have a manganese bronze guide, not just a soft bronze, but the manganese certainly gives this material some wear properties that are much superior to just standard bronze. And you can see on this guide we have an O-ring seal that when we put the guide in, anytime a guy services a guide, there's a chance for that bore to of course have gall marks or lines in it that of course oil can get through. So when you put in a replacement guide, it's a very good idea to have a seal on there so that we make sure we have a good seal and we don't get oil into the chamber and then into, of course, the ports. So we have two different guides. We have an intake and exhaust, and you can see that the radius on the exhaust is certainly tighter than what it is on the intake. The intake's got a nice long taper to it. On top of that, we put the guides in. We have a Viton seal here with a spring on the top to retain it. The underside of the seal basically mates with the guide that has I don't know if you certainly can't hear that, but there's a ridges on the guide that retain the seal, so they lock together and the seal doesn't come off. Moving on to, once the guides are in the head, we would assemble them with our valves. About the intake valve, it's a 1/900 valve. The stock one's about 100 thousandths smaller. And the exhaust valve that we have is, of course, the 1.615. The stock one's 1.575. So we're putting bigger valves in there so that we can get more air and of course, in and out. On top of those valves, when we get them in, we have a couple of different options on springs. We have a 585 beehive spring, and we have a 650 beehive spring. The difference there being, of course, this smaller spring for a smaller lift, and of course a lower seat pressure. This one runs around 125 on the seat pressure. The 650 spring will run around 170 pounds on the seat. So the reason why you'd want to kind of look between these two is if you're looking for a quieter engine, you're going to want a little less seat pressure. It's a little easier on the valve train. If you can stay below 585 lift, this certainly is the spring of choice. For the guys that want more lift and more performance, maybe you're not going to put the kit together the way we intended it to. You want to go even higher on compression for whatever reason. We certainly offer the spring to get the job done. So in a nutshell, that's how we do our step 4 and what the heads will have performed to them when you receive them back. Okay, now that we've completed stage 3, we've brought the bike back over here, put it on the lift and tore it down. We got the rocker boxes off, the exhaust off. We're going to replace the stock heads with the CNC heads. I'll start by removing the front head here and get the CNC head. We're going to need a new head gasket. Okay. Here again, applying assembly lube to the bolts. Under the head as well as the threads. And of course the torque sequence is the same for these as it was for the stock heads. There's 2 steps. On the first step you go 12 foot-pounds, 17 foot-pounds, 90 degrees. And then you untorque them and then retorque them 12, 17, 90. And then move on to the rocker boxes. So I'll go ahead and torque them out this time. Okay, 12 foot-pounds. Again, 17 in the sequence. Starting on the primary side, the lowest bolt or outermost bolt, and then crisscrossing over to the cam side. And now we need to do the 90 degrees. I switch away from my torque wrench and go to a long ratchet. I'm going to mark my bolts so that I can see how far I've turned them with a Sharpie. Of course, you can use some brake cleaner and a rag to wipe off the marks on the head bolts if they're external, like the ones over on the drive side are. And now I need to back them off and retorque them again.